Here x follows a binomial distribution with 10 trials and probability of success 0.2. We want to find the probability that x is less than or equal to 4. For this probability and this number of trials, we probably have tables supplied to us which cover these parameters. So n is 10 and the probability of success is 0.2. We can find this in our tables. We want the probability x is less than or equal to 4, so we look up where x equals 4. The tables we're supplied with are usually cumulative tables. So if we look up where x is 4, this gives us the probability of x being less than or equal to 4. And so we can read the answer to this directly from our tables, and if we do so, we get 0.9672. You should check that you can find this value in your tables. We now want the probability of x being equal to 5. From tables we have to use the probability x is less than or equal to 5 and then take off the probability x is less than or equal to 4. Since we have cumulative tables, when we look up x equals 5, we get the result for 5, 4, 3, 2, 1 and 0 added together. If we remove this, we remove everything except the probability of x actually being equal to 5. So if we look up in the tables, the probability of x being less than or equal to 5, you should be able to read off as 0.9936, and then we subtract 0.9672, giving us the probability of x being 5 as 0.0264.